Hey guys. Nice to see you all here today. And, really enjoy being in Armenia. I was dreaming for a long time to visit Yerevan. Nice city. So, quite impressed by architecture. So the speech to be done is about 3D graphics on the web and how to make 3D graphics with React. I think there have been many speeches like that, but the difference is that people speaking about 3D and React are normally just experimenting and showing you some small demos, which like, hooray, see, I have a ball rolling or something like that. But this one is a talk from a battlefield. So this is a experience we got by building quite big, one of the most expensive WebGL applications in the world using React, Redux, and WebGL. So experimenting with Unity3D. My name is Denis Radin, and you may find me in social networks as a Pixels commander. Currently work in a company FocusReactive, which is a high-class React consultancy, where every member of a team also do public speaking, and company invests into people, personal brand, in the open source they do, and into, say, ideas. So we don't just deliver code, but we collaborate on some nice open source ideas. And I do computer graphics for a long, long time. So chasing this holy grail, doing it efficiently. I started in 1991 when my father presented me the Spectrum, saying, some of you, so did anyone had the Spectrum? No, really? No one? Oh, I see, a few people still, hi oldies. Yeah, so it was a quite remarkable device with 48 kilobytes of memory and some resolution, which now you would say not enough even for a mobile. And yeah, interesting part of it, the whole screen, like that's a game running on the Spectrum. The whole screen was divided into 8 by 8 pixel blocks. And for every block of 8 by 8 pixel, you can have only 2 colors. So you see how this egg changes the color when moving behind objects or in front of objects. That's why, this is because you can have only 2 colors per this 8 by 8 pixel cell. I had a lot of fun with this thing when I was studying in elementary. So this was basically my entry point to development. Then I switched to C++ programming. I was doing some graphics there, mostly vector. And I switched to Delphi with DirectX, which was quite powerful. I was doing some 2D shooting games, etc., and arcades. Then I started to work. Like it's not about me finishing university yet. I was studying and I was working in a security company, delivering them CAD system. Like I did a vector engine and C#.NET. And it was pretty much like Microsoft Visio, but for security systems. So you can drag and drop tourniquets and some cameras, connect them with cables. It was really interesting. So I developed this engine from scratch. So later, it was quite interesting position and Flash development. Oh, let me show you. It was just for you to understand. It was 2008, so it was more than 10 years ago, or 2009. Yeah, that's our game. Yeah, it was actually nice. It was running completely in browser, 3D in a browser with the physics. Wow, it was nice. Then I started to experiment with HTML5 And I found like everything is pretty powerful. So we can do basically the same what was possible with Flash. So I was one of the first bit readers who start killing Flash, and I open sourced my game engine, which was Flash.js. It is still running. It's still capable to deliver some games with it, and it's kind of okay. By that time, it was interesting because it was the only HTML5 engine which allowed to make pseudo 3D games like that. So you have kind of 3D field. The rest were not able. So I was freelancing doing this kind of games for kids, for American company. And after that, I moved to Netherlands to work for the biggest internet provider in the world, Liberty Global, which is an umbrella company for companies like Virgin Media, you probably know, and many others. UPC in Netherlands, Ziggo in Netherlands, Vodafone is also, I think, a part of Liberty Global right now. We've been developing operation systems with JavaScript there, which was a lot of fun. Like it was a set-top boxes, TV boxes, which had pretty much limited calculation power, pretty much limited resources, and we bought 5 million of them, and we needed to run this operation system very smoothly. So at some point, we realized that using DOM, using HTML, CSS, doesn't give us the top performance. So we switched to WebGL, and I've been doing as user interface development with WebGL. As a result, I got quite interesting project called HTMLGL. Yeah, let me show you a demo. Hope it works. Yeah, it works. So the cool thing about it, now it's all rendered with the WebGL. Like, how this one is being done is you just wrap a piece of HTML, right? This is your HTML content. Then you wrap a piece of HTML with HTMLGL tag, and it becomes rendered by WebGL. It was super cool, and it gave some performance boost. So not only you've been able to make some really cool effects with WebGL, because yeah, now it is still like DOM. Oh, sorry, it is quite old demo, but so it is still inspectable, but you can apply pixel shaders. And once you change anything in an inspector or in an application, it also renders in WebGL. So it was a very efficient way of doing, of dropping HTML UIs to a WebGL to get some superpowers. Like, I don't know, whatever, twist or whatever. And then since 2017, I was, and I still work a bit with Evolution Gaming and do some work for Evolution Gaming. It was basically 3D games development. With WebGL and React. I was looking for this kind of a gig for a few years. Actually, not that many companies are investing into WebGL because it's hard to get money from there. If you do game for a mobile, you can easily sell it on App Store, right? But if you do game for WebGL, how can you sell it? Like, there is no store for WebGL applications until you pack it into some Chrome application or until you start making micropayments in there. And yeah, so Evolution Gaming do casino games, and there are a shitload of micropayments, of course, and they're making money in this way. But the whole idea is pretty challenging. We have a unified library of components written with React, which is a UI layer. So, for example, these buttons in the middle, this is a UI component, just a normal React component, actually. But then you see it's pretty rich 3D content with the reflections, physics-based materials, and all this thing is done with React and Redux, and we did a few games like that in Amsterdam, which is a 3D department of Evolution Gaming. Yeah, actually, as I said, because of the problems that companies do not invest into WebGL that much, because it's hard to get money from there, I think the number one oh, sorry. WebGL application by the date is Google Maps. You don't see that much of 3D there, but actually it's rendered with WebGL. But then these game applications are very advanced in terms of how are they componentized, how much of custom code was written to support that, and in terms of graphics quality as well. So as I said, there is a 3D layer, which is a WebGL, and there is also UI layer, which is just HTML, CSS, and rendered on top of it. So for 3D layer, we went with, what should we pick? How do you think? Because it's a lot of stars, right? No, we skipped this opportunity to work with 3JS. Oh, actually 3JS is amazing. I did quite some projects with it, and I think the potential of 3JS is big, but if you develop not a demo which just shows your ego how cool you are and how you can operate 3D objects and they're shiny, but you develop an application with a lot of logic and you need to keep a structure, then BabylonJS now is a way better choice for a few reasons. First of all, it's a bit newer. Second, they have a dedicated team. It's currently backed by Microsoft. So they have a dedicated team which works on the BabylonJS, and it means that people on a full-time, really good senior engineers are taking care of your problems. When with 3JS, it's just a community, which is also, BabylonJS also have a huge community, but it doesn't guarantee you that your problem, if you meet a problem, is going to be fixed soon, because as maintainers could be busy, or yeah, you know how it might happen. So BabylonJS now, I would say, is #1 3D engine. These demos are very simple. This one I like because it shows and demonstrates a physical-based materials which are a very strong part of BabylonJS. Oh, they have a lot of demos, and if you consider now to run some 3D project on the web, BabylonJS is maybe a way to go. Of course, it depends on you. Also, another thing is that 3JS have a community for a long time, and then they have to keep this community happy. Some people came from 2011 or something, and they don't want to get a new API. They are used to APIs they had for years. So currently 3JS is a bit outdated in terms of structure and how you build an application. So BabylonJS is built with and is developed with TypeScript, which is amazing when you build when you're building a big application. Right, so there was a decision, and now we went through points why we made a decision in favor of BabylonJS. Now, why ReactJS? It's mostly coming from the fact that It have a big ecosystem. There are a lot of developers building apps with React. So you can easily componentize and have a components library shared across the company, which is very important and saves a lot of time, and maintain it with a storybook or something different. I'm not sure what, sorry. Then state management, for us it was Redux. First of all, it was choice in head office in Riga. We have people working on 2D games in Riga and people working on 3D games in Amsterdam. And 2D games started before they picked a Redux. Then we picked after. There was a consideration to switch, but the problem with switching to something different is that Redux is perfect for building games for the reason that it operates actions. So games, it is not just an application which display data. They need some action. So action fired, you need to move an object or run an effect or something happens. But it's really hard to do, and it could be a consequence, like one animation then another, then three animation in parallel. So it's really hard to manage with something like GraphQL or MobX because it's less actions oriented, less events oriented. Okay, so now we have, as I said, 2D layer with HTML, CSS components, and behind the knees, 3D layer. They communicate through a Redux store. We don't do these fancy things like declarative React components which are being rendered to 3D. We tried doing that in Liberty Global, in a company I worked before as a TV provider. And the problem doing that is 3D world is a bit different. You do not update like once a second even. You update 60 frames per second. And if you start doing React or Redux updates 60 frames per second, it just doesn't work because of performance considerations. Like 60 updates per second on the React tree, it's a bit too much. So we took 3D layer from React declarative tree. It lives separately and it is connected to Redux. It's exactly how you see on a picture. And once selector's 3D component is connected to a change, it can react. It can react with imperative code, like something is changed, you start an animation just with a normal code. And a bit of a background how BabylonJS manages 3D and how it's built, the structure of application is built. So the elementary items, elementary artifact in a BabylonJS is a mesh. Mesh is just a single object. So if we go to this image of a blackjack, it's another game. Oh, yeah, it's exactly the game I was before. Then I will show a roulette, and yeah, I think the roulette. So everything is a mesh. Like table is a mesh, button is a mesh, every card is a mesh. You may think of a mesh like HTML element of 3D world. And mesh can be nested into mesh. I think buttons are wrapped into another mesh. So it is also a tree, like HTML tree, but it isn't 3D. And it consists not of HTML elements, but of meshes. So what we did is a Redux mesh. A Redux mesh, it is pretty much the same as React component in terms of API. Our lifecycle methods are approximately the same. I think I should change component will receive props to component update, but in the last version. But in general, the idea is that you have the same components, but for 3D. The difference is for React component, you have a render method, which applies this magic G6 transformation. But for Redux mesh, you don't have it. For 10 minutes. Oh my God. Okay. For React, you have only initial render, so there is no declarative stuff, and it saves us a lot of resources. So what are challenges when doing a 3D? Oh, any 3D engine sucks in building UI components. And as I said, you can combine it with just React components, and it works fine if you just put some static tables, static buttons. But if you need to stick to some space on a scene, you need something more advanced, and you need some know-how. So for example, these indicators, score indicators, they're just React components, let's see again, but they stick to a 3D, come on. They stick to a point in a 3D space. Like if you see, it is normal React component which follows the camera, and then once camera is getting further, it's getting smaller, and so on. So it sticks to a 3D point. Actually, it's possible. It is very simple. It is called for us HTML mesh, and how it's done for every request animation frame, it checks what is the screen projection of coordinate I'm given to be stick to, and it just moves itself to the screen projection. Oh, another big problem is performance regressions. Performance regressions is when you commit a feature and then FPS drops a little bit. You don't recognize it. So next team member commits another feature and it drops FPS once more, a bit. And then after a few weeks of working like that, you have a lot of features, but your frame per second rate is dropped like 20%, and nobody understood which point it happened because one of features was really critical for performance, or maybe set of features. So what we did is a continuous FPS benchmarking. We measure FPS after before every merge request, and on a build branch, and we build these graphs of average FPS, number of dropped frames, and longest junk, so longest consequence of dropped frames. What might be useful to know, you can run these tests on your automation tests, like you have automation tests probably, some of you, like end-to-end, and you have some scenarios. During the scenarios, you may run some benchmarking. Yeah, this is how diagrams looks, and Jenkins plugin for benchmarking, and for this thing we are now exploring. This is Google Data Studio, also trying to export data there. And another problem is that we as developers have too good hardware. So when you test on your laptop, which is a Mac with amazing configuration, it works too well. So you need to implement some low-end testing. For us, it was a big problem. So on a roulette game, we all understand how roulette game works. So at some point, ball starts jumping over the wheel, and then there is a game result, like ball stops at some number, and you are being shown are you won or lost, right? But we got a problem that ball was on red, gamer bet on red, but we've been showing you lost. The problem was that because of dropped frames, we've been never testing on dropped frames. We never had dropped frames because we have amazing hardware, and also phones where we've been testing on are amazing. So we always had 0 dropped frames. Then at some point, people with worse hardware started to play. It was like less than 1% of all players, but they started to complain. You show me that I'm lost, but I won based on how ball is positioned. And it was caused by per frame, keyframe based animation on a ball, and it was losing a sync with the wheel rotation when drop frames were there. So Oh my God, I don't have a time slider here to show. Yeah, that's you win situation. Doesn't matter. It was a pain in the ass, to be honest. Like many people complaining that you are cheating on us. So we've been fixing until 4 o'clock in the morning. And after this case, we decided that we should make this low-end testing. This is a scheme of a testing in the company. It's like 4 layers of testing. And it was still not enough because every layer, like developers testing with good hardware, automated testing still running on a pipeline and a good hardware, manual testing by dev team. They mostly have, it's like 1 drop frame is not enough. Even if you have average phone or iPhone 6, it was not that bad. So the whole this pipeline of testing passed through this issue, and it happened to be like 4 a.m. coding. So then we released a Chrome extension, which is FPS control, and now we can test with drop frames how it works. So basically, you can pick number of dropped frames, and it starts to drop frame. So yeah, if you let's see again. Now it's going to be 90% of dropped frames, and you see that it's lagging, or you can pick 25. So now we are sure that we can emulate dropped frames, and we will never miss the issue connected with this kind of low-end testing stuff. So the first problem is a big one, designer to developer interaction. Normally there is a new asset, hey, I have a new chair, designer says. Then developer starts to integrate asset into a game, and then it shows the result to a designer. Hey, this is how your chair looks in the game. And it can take an hour or 2 or 3. It depends how busy they are and if they had lunch or are still eating, etc., etc. So it's getting a bit painful and takes a lot of time. But major game engines as Unity or Unreal 3D have amazing IDEs which allows designer just to drop a chair into the game with drag and drop and check a new chair. So we were thinking like, should we try to use Unity as a platform? Do you know what Unity is? Okay, yes, Unity is famous. Not as the Spectrum. Yeah, okay, then let's proceed. Yeah, Unity have what you see is what you get editor, which is very nice actually, and it allows to check new materials or is this drag and drop way. So with BabylonJS it's harder. I will tell a bit more later, but still there have been some problems with Unity. Another problem we've seen is assets reusing. Once I had a task to implement a lightning on a roulette game. Lightning special effect. So you pick some numbers, you bet, and then okay. And some lightnings. Yeah, so I did it well. Like I went to internet, to Wikipedia, and then I explored how it works, how lightning strikes, and like I spent 2 weeks on making this effect. But then I went to Unity store and I found that effect for lightning, which is amazing, costs 5 years. And like, what? I spent 2 weeks, guys. So all these stores, and Unreal and Unity have these stores, they help to save money. So we thought like maybe we should seriously consider Unity. But there was a problem to use Unity with UI, so we started to work on a framework to connect it to Redux. And we made a React Unity project which allowed to integrate Unity projects inside of React application, and started to make a Redux middleware to make Unity project listening Redux stuff and dispatching Unity. But then the problem with Unity is that just a simple build is 20 megabytes. So we dropped this idea. Now they develop Unity Tiny. Now it's in development. And Unity Tiny is going to be a small runtime of 100 kilobytes for Unity, which also supports TypeScript. But actually, BabylonJS progressed very well. They recently released the version number 4 with amazing inspector, which makes us think about, do we need Unity at all or something like that, because what these guys are doing in Microsoft is amazing. And they basically building a clone of Unity with web technologies, and it's built with React. All the thing is IDE, which is Unity-like, is built with React. So if you want, you can commit a feature, and then they most likely accept if it's meaningful. So now we have free Unity-like tool on the web, which is cool. Right, I think I'm done. Yeah, thank you guys. Whew.